Welcome to The Explainer. Today, we are diving into a deeply counterintuitive meteorological mystery, and it's coming straight out of the Himalayas. We're looking at a brand new 2025 study analyzing decades of climate data from the Kathmandu Valley in Nepal. And honestly, what it reveals is fascinating, but also pretty alarming. We're essentially seeing a complete rewriting of the rules of extreme weather, and all the clues are buried right there in the data. I mean, just think about this for a second. If a region is statistically experiencing fewer extreme rainy days over the course of an entire year, why are its flood disasters getting exponentially worse? It sounds like a total paradox, right? Well, that's exactly the mystery we're going to solve together today. Because to crack this case, we have to look way beyond just the total amount of rain falling. We need to look at the behavior, the intensity, and the timing of every single drop. To understand why the weather data is behaving so strangely, we first got to look at the geography itself. The Kathmandu Valley is essentially a giant geographical bowl. It's surrounded by these massive hills reaching up to 2,800 meters, but it really only has one single natural drainage outlet. It's a gorge at a place called Chovar. So when water pours into this bowl, it doesn't have many ways to escape. It's a massive geographical bottleneck just waiting for a surge. And here is where the timing becomes absolutely critical. A staggering 80% of the valley's entire annual precipitation falls in just 4 monsoon months, from June to September. The whole region depends heavily on this massive, concentrated seasonal dump of water. So picture it, you've got a bowl-shaped valley, a single drain, and 4 months of intense monsoon. That's our baseline. But what happens when climate change starts tweaking that baseline? Well, that brings us to Section 1, the rainy day paradox. Let's jump right into the data from the new study tracking daily rainfall from 1980 all the way to 2022. It presents a really stark, terrifying contrast. The overall number of extremely rainy days, that's actually going down. But at the exact same time, the sheer volume of water falling during a continuous week-long stretch is going way up. The atmosphere is basically holding on to its moisture longer, only to unleash it in violently concentrated week-long deluges. Now, to properly read these clues, we kind of need to speak the language of meteorologists. The World Meteorological Organization uses these specific indices to track climate extremes. So when you hear RX 7-day, we're talking about those rising weekly deluges. R35mm tracks those standalone extreme rainy days, which, remember, are dropping. CDD measures consecutive dry days, and PCI tells us how wildly irregular the rainfall concentration is becoming across the year. Keep those in your back pocket. They are the keys to our paradox. Moving right along to Section 2, fewer days, heavier downpours. We really need to shift our focus to the sheer alarming intensity of these newly condensed rainfall events, because the rain isn't just falling anymore, it's literally being dumped out of a bucket. The data reveals this crucial number, negative 0.05. That is the yearly decrease in the number of days experiencing extreme precipitation of 35 millimeters or more. Over a 42-year period, those standalone heavy rain days are vanishing. Now you might think, oh great, less extreme rain days means less flooding, right? Wrong. Because the water hasn't actually disappeared, it just completely rescheduled its arrival. And the human cost of that rescheduled arrival is starkly mapped out in recent history. Back in 2002, a massive anomaly brought 177 millimeters of rain in just 24 hours. Jump ahead to September 2021, and a 121-millimeter event causes severe, paralyzing inundation. Then we hit the nightmare scenario, September 2024, a staggering 239.7-millimeter deluge in just 24 hours, resulting in over 200 fatalities. The bowl simply filled up way faster than that single drain could handle. The researchers sum it up perfectly with this quote. The crucial point here is that the threat profile has entirely shifted. It's no longer just about managing a predictable, months-long monsoon. It's about bracing for sudden, unexpected, highly concentrated extreme deluges that can completely overwhelm infrastructure in a matter of hours. Which brings us to Section 3, the dry spell dilemma. Because every coin has two sides. If the rain is condensing into tighter windows, what exactly is happening to the rest of the year? Well, while the deluges get heavier, the droughts are getting longer. Consecutive dry days are actually increasing by 0.69 days every single year. When you compound that over the 42 years of the study, you're looking at significantly stretched out dry spells. The soil bakes, it hardens, and it loses its ability to absorb water, which ironically makes the flooding even worse when those intense deluges finally do show up. We can see exactly how out of whack the year has become by looking at the Precipitation Concentration Index, or PCI. Summer sits at a value of about 9, which is classified as uniform, so the monsoons is still relatively reliable. But winter jumps to a 16, which is classified as